Okay everybody, we're just going to do a little tutorial here and I'm going to show you exactly how to do the structural geology lab, diagram by diagram. So what I did is I just took a screenshot of the page for the structural geology lab and drug it straight into Microsoft Word here. So all I'm going to do now that I have the image in here is I'm going to go over here to draw, and I'm just going to select some kind of a pen here that's going to be used to draw in our structures. Actually, let's use yellow, orange, there we go. And this looks pretty good. So let's just start with the basics here. The first thing we want to do is figure out what kind of fold we're looking at. Now, the strike and dip symbols point towards the middle of this fold. This is the middle layer right through here. So I know that this has to be a syncline. And it says that the rocks are dipping at 30 degrees. So I know that rocks on this side of the fold are kind of going like this. And rocks on this side of the middle layer are kind of going like this. So they're going to go around like that. I know this is a non-plunging fold because on the sides the layers are parallel to the surface, okay? So I don't have to worry about that. So all I'm going to do here is just try to make these loop around. I'm drawing this with a mouse, so it's not very good, but you'll get the idea. So it goes like this. And then I'm going to do these guys over here. This is going to do the same thing. All of these guys are going to be dipping in the same way, sort of parallel to each other. This one's going to come along like this. And this one's going to go down like that. I do not know what's below this sort of brick-like layer here, so I'm just going to leave that one. And I can shade in a couple of these just so I can see what the structure looks like, that this is indeed a syncline. Maybe this dark colored one over here I can shade in, and that's going to let me know that this is a nice little fold here. We don't want to spend a whole lot of time worrying about drawing this in. Again, this is kind of a ugly looking picture, but I think we get the idea. Alright, so strike and dip here, strike and dip here, both pointing towards each other. I know this is a syncline. If I had to draw a strike and dip symbol at A and B, I'm not worried about that, but if we did, they would look like that. And this strike and dip symbol would look like that, kind of aim towards the middle. Okay, so there is a non-plunging syncline. Let's go down to this one. Now I see that the strike and dip symbols are pointing in the opposite direction over here and over here, so I know that this guy is an anticline. And that this bed right here is the middle layer. So I'll draw a little dashed line here that shows that plane. So these are dipping to the right, so I know that this is part of the same rock unit, so I'm just going to draw a line that connects that contact with this contact that represents the bottom of this polka dot unit. This is going to come down like this, and this guy is going to come down like this. So this dashed unit right here is the same, and I don't know where the bottom is. So the right side of the fold here has a wider outcrop pattern, and that means that these are dipping at a lower angle than they are over here. This is the same rock unit here and here. So on this side, the rocks must be dipping at a steeper angle because of their narrow outcrop pattern. So I'm just going to draw it like this. I don't have angles here for the strike and dip, so I don't know what the correct dip angle is, so I'm just going to kind of estimate that it looks something like that. And there is my fold. Okay, kind of asymmetrical, so the axial plane would sort of dip down, maybe something like that. And again, I don't know what's going on down here. I don't know where the bottom of this dashed unit is. But what I can do is draw something called form lines, just so I kind of get an idea of what that rock unit is doing down there, that it is indeed folded into an anticline. So I'm going to draw sort of a dashed pattern like that to show what's going on down there. Strike and dip symbols, if I wanted to draw them at A and B, I know that over here the rocks are dipping to the left, and they are also dipping to the left over on this side because it's on the left-hand side of the middle of the fold here. Okay, so we've got an asymmetrical, non-plunging anticline. So if we go down to this guy, what kind of fold must we have? Well, the strike and dip symbols are pointing away from the middle of the fold right here. So I know that this must be an anticline. And because it has a horseshoe-shaped or U-shaped outcrop pattern on the surface, I know that this is a plunging anticline. Let's start with this side here. I don't know the dip angle, so I'm just going to kind of estimate that this is going to go down like this, and this is going to go down like that somehow, following these strike and dip symbols right here. I don't know what's below this rock unit right here though, so I don't know where the bottom is, so I can draw in form lines that kind of show that this is an anticline like I did before. And then on this side, we know that anticlines always plunge down towards the nose, so it's going to be plunging in that direction. So on the sides, these aren't going to be horizontal, they're going to be plunging down in this direction at some angle. I don't know what the angle is, I'm just going to draw them kind of coming down like this. Here's this guy, here's this dashed layer, and it's going to look something like that on the sides. Okay, so if I were to draw strike and dip symbols here, the contacts between the different layers represent the strike lines, and I know that it's dipping away from the middle, so it's going to be going off like this. Right here on the nose of the fold, the strike is going to be this direction, and the dip is going to be towards the nose like that. And over here at C, the strike and dip symbol would look like this. Again, the strike is parallel to the contacts between the layers, and it's dipping to the right in this direction. So there is our figure C, plunging anticline. Let's continue down here. So this one, wow, looks kind of problematic, right? Because where are the strike and dip symbols? How do we know what kind of fold this is? And it doesn't tell us where the youngest rocks are. They happen to be right here. So this is the middle of the fold on this diagram right here. The question is it an anticline or a syncline? I know it's plunging because there's a horseshoe-shaped outcrop pattern here. Delete that. But this little bit here gives me the clue that it must be a plunging syncline because it's going down in the opposite direction of the nose. So on this one, I might be able to just kind of draw these lines. I'm just going to kind of continue what they already started here, like this. This is going to go down that way. So this is a syncline because it plunges down away from the nose, which means that this gray layer is just going to do this and link up with the other side over here. Again, I don't know the exact dip angles here, so I'm just kind of estimating. And this guy is going to be going down this way and maybe up there a little bit. This is going to be going down that way. Okay? So what would the strike and dip symbols look like on this? Well, the rocks are dipping towards the middle of the fold here. So at D, the strike is going to be right about like that. There's the dip, strike, dip, strike, dip. And then over here at B, right at the nose of the fold, strike's going to be like that, tangent to this curve, and the dip is going to be going in that direction there. Okay. All right, so we've got a plunging syncline down. So let's keep going. Let's look at this guy. So this is a tricky one because it's combining a fold with some type of fault here. So first things first, what kind of fold are we looking at? Well, this one does have strike and dip symbols, and they are pointing towards the middle layer right here, so I know that this has to be a syncline. Okay, these are dipping to the left, and these rocks over here are dipping to the right. So it's kind of like the first diagram we did. So I might as well just go ahead and get that done and draw the syncline on the front of this fold. So this one, I'm not sure how far down it goes. I'm just going to kind of estimate. I know it goes over here somewhere. Not the best curve there. But now I'm not really sure what goes on down here. I'll have to think about that in a minute. But I've got the basic fold sketched out here. And it says that there's a fault that goes through here that's dipping towards the front of the diagram at 45 degrees. So I'm going to draw this fault like that. 45-degree dip. Now, I know that this is the bottom of this brick layer here, so I'm going to just sketch that in. And I know that over here is my polka dot layer. These little symbols on it. Over here, I could draw that straight, it'd be helpful. There we go. So let me try to draw a straight line here. There we go. This is our little straight line unit here. And then down here, I have this dotted unit. Okay? So now the question is, what goes below the brick layer here? What's the next layer down? Well, on top here, I'm missing this dark layer, but I have this dashed layer, and I know that this must represent the middle portion of this fold here, because these are the same as these over here. So the syncline continues on this side. So if I go away from the middle, the layers get progressively older. Okay? So this is the youngest layer on this side of the block. And then this gets older, 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 and oldest down here with these. So I know that the rock layer that's older than this brick layer has to be the polka dot layer. So I will go ahead and draw that layer in right here. So this layer is offset this way. And here is the layer drawn in. And below the polka dot layer, I know is this lined layer right here. So I could just go ahead and draw that in like this. And then I can draw it on the face, the front part of the diagram, like this. So here is our polka dot layer. Hard to draw these quickly, but try to not waste time. Here we go. And then here is our lined layer kind of going down like this. Doesn't look like I have enough room to put this dotted layer down, but it would be down underneath here somewhere. So this block right here is above the fault, so this is the hanging wall. And this block right here that's below the fault is the footwall. If we were to draw a tunnel in here, we would be walking, put our feet here on the footwall and hang the lights from the hanging wall up here. All right, so now the question is, what do we have? What kind of fault is this? I know this is a dip slip fault because some of the rocks have been eroded off of this side, namely this darker layer right here. It's not present here on this side. And if I look at this striped layer, it looks like this block moved down relative to the footwall block. Okay? So what kind of fault involves the hanging wall moving down? It is a normal fault. Normal fault. And I actually know that for two reasons. The easy way is to kind of look at the side. I know that this isn't a lateral fault because the rock layers are kind of symmetrical. So we took this syncline and this side went down. This side was left high and dry. So it eroded down. And some of the younger layers, including this dark layer, were eroded off. So what we're seeing on the footwall is basically this little bit right here. Where this portion right here got eroded off of the footwall. So that's why if this is this little dashed layer right here, that's why we only see the very bottom of this dashed layer on the footwall block, okay? Because this portion right here eroded off of this side. Okay, a little bit confusing, a little bit more higher level than what we did before because it involves this fault here, okay? Let's move on and do this last one now. Okay, so mission number one, what kind of fault are we looking at? It says that the youngest layer is right here, and this is the same layer over here. So if the youngest layer is in the middle, it must be a syncline. So I'm going to start by drawing a syncline here. I'm not sure where that gray layer is, but it's kind of going somewhere like that. Here's the dashed layer. And here is this brick layer. It's going to go something like that. And that's all I have so far, so I know I have the basic shape of the fold. It says earlier that this is some kind of fault that's dipping 45 degrees to the front. So I'm going to draw it in the same way as the other one. But this isn't a dip slip fault because I have all of the same layers on both sides. And if I look at the middle layer right here, it's offset. As I look across the fault, the rocks are shifted this direction to my right. So this fault must be a right lateral fault. Right lateral. Okay. All right, we'll worry about the fault here in a minute. Let's try to figure out what goes below the brick layer. So again, youngest layer, older, 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 and this one would be the oldest layer that we see in the entire diagram. So over on this side, let's just kind of complete this side first. I'm going to draw straight line here. This is a non-plunging fold, just like this one up here was a non-plunging fold, because the outcrop pattern are made of straight lines rather than a horseshoe shape. So what comes under this? Well, if I look over here, this is the next oldest rock layer, the polka dot layer again. So I'm going to draw that over here. This is the brick layer right here. I'll try to draw some kind of a brick pattern here. Not the best. And then here is my polka dot layer again, right here. And I can continue this on the front of the diagram. Here's my polka dot layer. And right above it is the brick looking layer. These are all legitimate geologic symbols, by the way. This is actually the symbol for limestone, this brick pattern. And I'm kind of not drawing the most pretty picture here, but hopefully you get the idea. Wow, I'm just butchering this. I'm just going to stop. You get the idea there. All right, so what comes under this? This kind of grayish layer. So the bottom layer down here, and I don't know how deep it goes, so I'm just going to assume that it goes really deep. That's going to be this guy right here. So this layer right here is the same as that layer right there. I'm not going to bother trying to shade that in. All right, so what's going on over here? This is the dashed layer right here. So I'll just kind of continue this over this way and draw the dashes like this. And what comes under the dashed layer? The brick layer again. Okay, because again, I can go older as I go to the left here, away from the center of the syncline. So I'll draw the brick layer maybe somewhere around here. And I'll try to make it look a little bit like the real brick layer there. Okay, and then what comes under the brick layer? The polka dot layer. So here's the polka dot layer right down here. Okay. All right, so we have a right lateral fault that makes an apparent dip slip motion on the side here. It looks like, because this would be what we would call the hanging wall, and this would be the foot wall if this is really dipping down in this direction towards the front of the diagram. But it's really not a dip slip fault at all. It's just a right lateral fault. So whenever you cut dipping layers with a right lateral or a left lateral strike slip fault, you get an apparent dip slip motion on the side. For the extra credit blocks, you see this on figure number 12. But it really is not a reverse fault. It is just a strike slip fault. Okay. If I had to put strike and dip symbols here, I know this is a syncline. There's my strike, there's my dip. This guy is going to dip this way. This guy is going to also dip this way because it's on the right-hand side of the middle layer. C is going to dip this direction towards the middle. D is going to dip that direction towards the middle. All right. So let's look at these dikes right here, and then we'll look at the age of the faulting too. So the first thing that must have happened is dike Y must have come in and continued all the way over here. Okay, so this guy would be the oldest. And then it was offset by this right lateral fault because it's cut by the fault right through here. Okay, so oldest, middle would be the fault. And then finally, dike X cut through all of them. So dike X has to be the youngest. In fact, it's even younger than the youngest layer here, right? Because it cuts across that gray layer. All right, so hopefully that was helpful. Go ahead and knock this out if you are still working on it, or if you've completed it but weren't happy and didn't quite understand this. Hopefully this can help. If you resubmit it via email, I will give you some extra points. So if you didn't get it 100% correct on the lab and you redo it and send it to me, I'll give you an extra 3 points for completing them all correctly. All right? And again, as always, let me know if you have any questions about the lab if you don't understand.